Okay, hello. So in this video, I'm going to show you how to do example 10. You should definitely try example 10 on your own. It doesn't use any new tricks, so the only things you need to know for example 10 are the replacement rules, left and right replacement, and the constraint trick. So if you know those two things, you should be able to put this together. And this is actually a great example of the kind of question that uses both, and you got to be careful and choose your constraint carefully. So this is a great practice problem. Don't ruin it by not trying it before you see the video. Even if you only write down the definition of the proof before you start, that's totally fine. So at least do that. Okay, so here we go. Want to show, what do we want to show? Where's my mouse? Here's my mouse. We want to show, and I need the limit as well. Okay, for all epsilon greater than 0, there exists a delta greater than 0. So that what? 2 over x minus 3 minus 7 whenever x is between what and what. Okay, I think I screwed something up here. Okay, again, math is about making a mistake and then fixing it. That's the skill in math. The skill is not getting it right the first time. So x is going to 7. X is going to 7. That's good. And here I wrote minus 7. That's not right. Minus 7 should be minus 1/2. Okay. So what are we given? We are given an epsilon greater than 0, and we want to explain why we can find delta so that what? 2 over x minus 3 minus 1/2 is less than epsilon. How is that implied by 0 less than x minus 7 less than delta? Okay, so here we go. As always, we're going to start at the end here. 2 over x minus 3 minus 1/2 less than epsilon, and we are aiming to get to x minus 7 less than delta. Okay, first up, I think we're just going to do some simplifying. I don't see where the x minus 7 is yet, so I really don't see it. So I'm just going to like hit this thing over the head and try to simplify it until x minus 7 appears, and then maybe I'll formulate a plan once we get there. Let's try it. So I got a fraction. Why don't I add the fractions together? So let's do 2 times 2 over 2x minus 3 minus 1 times x minus 3 over 2x minus 3. Common denominator, that thing. Okay, and then I add them together. So 4 minus what? 4 minus x minus 3 in brackets, x minus 3. And it's absolute value, so I can do them separately. Why don't I just do this as a step? That thing's on top. On the bottom, I got absolute value of 2x minus 3. Great. All right. And then simplify a little more. 4 minus x, but then plus 3. 4 minus x plus 3. I'm trying to think if I made a mistake here or something. Okay, yeah. 4 minus x plus 3. Okay, it's good. 4 minus x plus 3. Okay, this is why it's good to do it slow. Don't mess up your minus signs, or you're going to have a bad day. Okay, less than epsilon. And 4 minus x plus 3 is also known as 7 minus x. Okay, all of the steps so far are reversible. All we've done is rearranging the equation. And now I can see the target. The target is x minus 7. I have 7 minus x, but it's inside an absolute value. And inside an absolute value, you can flip things around. Flipping things around is just a minus sign. It's multiplying by minus 1. And the absolute value of a minus b is equal to the absolute value of b minus a, because they're different by a minus sign, and the absolute value of a minus sign is 1. So you could formally write absolute value of a minus b is absolute value of minus b minus a, which is the absolute value of minus 1 times the absolute value of b minus a, which is just b minus a. So it's okay to flip inside an absolute value. So let's do that. Let's just flip this. If and only if x minus 7 over 2x minus 3 less than epsilon. And now we're in the zone here. We got this x minus 3 junk. the whole problem is going to be getting rid of the x minus 3 junk. So you could get rid of the x minus 3 junk over here, and you have to be careful because it's in the denominator. So it's not actually x minus 3. It looks like x minus 3, but it's not. It's 1 over x minus 3. So that can ruin your day. So to be really sure that I don't screw things up, I'm going to move it to the other side. So I'm going to move it to the other side. X minus 7 less than 2 epsilon times x minus 3. And okay, this is an important point. It's only okay to move this stuff over if x is not equal to 3. If x equals 3, then this statement makes sense. But the previous statement has a divide by 0. So you need to ensure. Let's just ensure x is not equal to 3, and we can make sure that x is not equal to 3. That'll be okay because we're talking about the limit as x goes to 7. So to ensure that x is not equal to 3, all we have to do is look at values that are close enough to 7 that they don't include 3. So to ensure that x is not equal to 3, we can make an assumption on our delta. So to make sure x is not equal to 3, you can work it out. So you want to get something implies x not equal to 3, and you can work it out. It's okay if it takes you a little bit, but what it's going to be is the difference between 7 and 3. So as long as delta is less than 7 minus 3, that's 4. If delta is less than 4, then x definitely won't be 3. And so you can work that out and double check, but that's like a good thing to ensure. So maybe at the end of the problem, I'm just going to make sure that delta is less than 4 by doing the minimum thing that we did before. Okay, so x minus 7 less than 2 epsilon times x minus 3. And we would like to get to x minus 7 is less than delta. So all I got to do is replace out the 2 times x minus 3. I got to replace that out to get my delta. So this to me smells like a right replacement rule. We're going to replace on the right-hand side. So I'm going to make a lemma. Let's make a lemma. Lemma. We're going to replace 2x minus 3, and we're going to do a right replacement rule. In the left replacement rule, you want to have the thing you're replacing is less than something. In the right replacement rule, the thing is a greater than something. So this is going to be greater than something. I'll call it b, and that's what we want. And once again, it's not true that x minus 3 in absolute value is going to be greater than something useful over here. Like it could be true it's greater than 0, but that's not going to help us because we're going to get a 0. That's going to be bad. So just like before, we're going to need to use the constraint. And so we're gonna say that when x minus 7 is less than something, because it's less than, so we're going to assume delta is less than something, and then that'll give us that x minus 7 is less than the something, and that should lead us to 2x minus 3 is less than b. So we just have to pick a value, and you can pick a value and try it. So what I'm going to do is I'm going to try the value 1 is always a good guess. Let's try 1. Let's try 1. Assume delta less than 1. Actually, guys, look, we're already assuming delta is less than 4. Why don't we stick with that? Let's assume delta is less than 4. So we're going to try to prove this thing now, the lemma, that if x minus 7 is less than 4 in absolute value, then 2x minus 3 has to be greater than some b value. And if we can make this work out with a b value that is positive, then we can do a replacement. B equals 0 is going to be no good because then we're going to get like a delta equals 0 epsilon, and that's not allowed. So okay, so let's try it. So x minus 7 is less than or equal to 4. Okay, that's the same thing as x minus 7 is between 4 and minus 4. Now we can add 7 to both sides. That's the same thing as 3 is less than or equal to x is less than or equal to 11. Okay. I want x minus 3 though. Why don't we subtract 3 now? Because look, I'm looking for x minus 3. X minus 3, 8, and 2. 0. X minus 3 is bigger than 0. So like in what I've done so far, I've done if and only if arrows. Everything is, there's no room to fix things. And it could be that x minus 3 equals 0. And if x minus 3 equals 0, this b value is not going to work. It's gonna work out to b equals 0. So this is no good. We got to try again. So got to erase and try again. And I think the problem was that this 4 range, 4 and minus 4, was too big of a range. We got to do a smaller range. So let's try a smaller range. Let's try. So we're gonna back up, and this is like a normal part of math. You gotta do it. You gotta try again. Let's do something smaller than 4. Let's do 1. 1 is a nice number. 1. Okay. So we're starting with x minus 7 is less than 1, and that means x minus 7 is going to be between minus 1 and 1. Okay, now we add 7 to both sides. 6 is less than x is less than 8, and now we can subtract 3. X minus 3 is less than 5 is greater than 3. Okay, and we want absolute value of x minus, this is what we want, is absolute value of x minus 3 with a 2 is greater than b. Okay, well, the 2 is silly because we just move that over and call that b by 2. And x minus 3 bigger than b over 2 by the sandwich property, that is saying that x minus 3 is bigger than b over 2, or x minus 3 is going to be less than negative b over 2. Okay. X minus... Hold on. We have 3 is less than x minus 3, and here this is x minus 3 bigger than b over 2. I think we're in business as long as we set 3 to be b over 2. And that's b equals 6. So let's try b equals 6, and hopefully this will work. So I'm going to go back. And again, totally okay to try it and have it not work. We're going to set b to be 6. B over 2 is 3. X minus 3, absolute value of x minus 3 is greater than or equal to 3. 2 absolute value of x minus 3 greater than or equal to 6. That's going to be the last line. Okay, that's good. And that means x minus 3 is going to be bigger than 3, or x minus 3 is going to be less than minus 3. Okay, so all of these lines are good. Okay, and look, x minus 3 is bigger than 3, and it's also less than 5, but that's not helpful. We just need, if this one is true, then that one is true. If x minus 3 is bigger than 3 and less than 5, x minus 3 is trapped between 3 and 5, then definitely x minus 3 is bigger than 3, or this other stuff. This or stuff also doesn't matter. So I guess if you want, let's do one more line. That implies 3 is less than or equal to x minus 3, right? If it's between 3 and 5, it's definitely bigger than 3. And that means, not if and only if. One way. If x minus 3 is bigger than 3, then x minus 3 is bigger than 3, or some other stuff. It doesn't matter what the other stuff is. We got the first part. And that's the same thing as absolute value of x minus 3 bigger than 3. Okay, so we have the lemma. We have the lemma with a 6. So as long as delta is less than 1, we're going to be okay. So I'm going to go back to my proof now, and I'm going to do a right replacement rule, replacing 2 times x minus 3 with 6. So x minus 7 is going to be less than 6 epsilon, and this is by the right, this line, this implies, nope, not implies, backwards arrow. Right replacement rule is with the backwards arrow. So you could double check that, the right replacement rule, that you know which way it's going. It's like this. By the right replacement rule and the lemma. Okay, and that works as long as delta is less than 1. So as long as, okay, because the lemma says assuming delta less than 1. Assume delta less than 1. Okay, and so now we got it. The last step is going to be true. Okay, and I ran out of room here, but the last step is going to be true as long as delta is less than 6 epsilon. Okay, and then, okay, there's the traditional last step of adding the 0, x minus 7 less than delta. Okay, so now we got it. Delta must be less than 6 epsilon. Delta must also be less than 4. delta's got to be less than 4, but also delta has to be less than 1. So you could do a minimum with 3 things here. So the set delta is going to be the minimum of 4 and 1 and 6 epsilon. And that way, all 3 conditions will work. Definitely delta will be less than 4. Definitely it'll be less than 1. Definitely it will be less than 6 epsilon. 4 and 1 is kind of redundant. 4 is never going to be chosen to be the minimum. So you could also just write minimum of 1 and 6 epsilon. Okay. And that, okay, it's over my picture. Here we go. And that is the proof.